Howard Toomey is a software security architect with extensive experience in information security technologies, enterprise product management, software development, and electrical and computer engineering. He spent his first 10 years coding enterprise security software solutions. His next 11 years interfacing with customers and telling engineers what to build, and 2 years using software solutions in an IT operational environment. Howard now does product security, ensuring source code is free of vulnerabilities and writing security bulletins when issues are discovered externally. Let's welcome Harold, sorry.
Testing. 1, 2, 3.
Sorry.
Okay, I think it works. Should I be worried that my presentation started with my water bottle falling and half the water on the ground? That should be fine. Okay, well, thanks for coming. I know this is getting late in the afternoon, and you don't have to be here, but I have something I'd like to share, a problem that we had where I work. I work at Intel Security. I used to work for a company called McAfee, and McAfee got acquired by Intel about 3.5 years ago, and they gave us all blue badges in July and said, you're now Intel, you're not McAfee. And so we're Intel Security, and one of the things I do in my job is I work with the engineering teams that develop the 110 plus McAfee products, and I make sure that they know how to do threat modeling, security reviews, you run the right tools, and build security into the products. And when they don't do that, we respond with patches and security bulletins and frowns. Okay, so that's what my day is like. And as I've attended a lot of these other presentations, most of them seem to be focused on IT security. And these are what happens when you already have a solution in your hands and you're deploying it into your enterprise. If you go upstream a little bit more, you'll be in my world, which is developing the tools like an antivirus tool or a SIMM tool or a vulnerability scanner tool that is used by IT and ensure that that tool is free of vulnerabilities. Because if you think about it, the worst thing you could have is if you buy a virus scan product from Intel and it has a vulnerability and the very tool you bought to protect you is now a vector of attack from a hacker. That would be a worst case scenario. So we do everything in our power to prevent that. So what I'd like to do is just go over some of the things that we do to secure software and then take it to the next level. And I thought if I get your attention with this great title, ISO 27034, that would get your attention, but probably not. Does anyone here know what ISO 34 is even about? Okay, I will go through that. But I'm going to cover the what, the when, and then the how. The what, just to build up what we're doing, ISO creates standards. The standard I used when I was in IT security was ISO 27001 and 2. And those are used to secure your IT environment. And there's several others. The number 34 standard is for application security. So when you're building software, what processes and things do you need to follow in order to ensure that you're doing it right? And so this is an emerging standard. As you can see, it comes in 6 parts. And parts 1 and 2 have been released already. In fact, number 2 is just barely released. And the other ones are being worked on. So again, this is a growth industry. And these indicate what needs to be done. It doesn't go into much detail. In fact, it's amazingly vague. I was asked to map our processes to this, and it was amazingly vague. But we were able to do that. And so every company that develops software has an SDLC, a software development lifecycle. We started out 10 years ago using a modified waterfall technique. And now at Intel Security, we're over 90% of all our development teams are agile. And so with Agile, and with any other SDLC, you design, you build, you verify. With Agile, you build things in what's called sprints. And in these sprints, the idea is you complete a feature in such a way that you could actually ship that product potentially at any given time because you're functionally complete. That's the idea behind it. Waterfall, of course, is you just build something for 9 months and test the heck out of it and hope it ships. And we found that that's not very effective. And then if you dig down deeper and look at how Agile is, and I'm just showing this to show you that there's a process and tasks that we do before I get to the real topic, is we go through this process here where basically engineers are in various phases of the product with various checkpoints. And by the time they're done, we ship a product, finished product, and then I'm part of the post-release sustainment if we have to do vulnerability patches and whatnot. So if you look at each of these black boxes here, the question is, when do you do product security? When do you do these things? Because product security is, I'm going to call it synonymous with software or application security. It's a process that should be built into each of these phases. So if I took each of those black boxes, I could say these bulleted lists are the items we require our engineers to do or consider at each of these phases in the development lifecycle. And so you can see there's a lot of different tasks. In some cases, a task may not be relevant, depending on the scope of the project, if it's a mini update or a major release, different things, what platform it's on. But in general, these are the activities that have to be done. And most of them are done during a sprint, which is to say it's when the engineers have like a 2 to 4 week window where they all focus on the feature set and the user stories and get it done. So if I were to take all these things from the processes and the deliverables, you'll find that in general there are 8 different operational parameters that we're looking at, from the program, your resources such as tools and people, and SDL. And SDL is a secure development lifecycle. It's like an SDLC, but only focusing on the security aspect. PSIRT is Product Security Incident Response Team. It's what happens when we get a vulnerability in a product, and it's a medium to a high severity risk, and we got to patch it quickly. Process training, reporting. And then this is on the programmatic side, which is what I spend a lot of my time on. And then in addition to that, we have what the engineers are spending their time on. They're focusing on these 12 buckets of security tasks. Some are tools, some are activities and whatnot, things that they do to ensure that security is built into a product. And I'll get back to this list later. I just wanted to show you that there's a lot of activities that need to be done. So the problem we have at what was McAfee and now Intel is we haven't a well-defined SDL. We know what the engineers need to do. Now, how do we measure how well these product teams are doing that? Are they doing a quick and simple checkbox, or are they doing it so well that it really is well worth their time and delivering the results we'd expect? And you get the whole range depending on the individual, the team, the project. Now, one of the first things you might think of is, which is good, is let's look at a SDL maturity model. And I first learned about maturity models from Gartner when I was a product manager, where every technology goes from being born to being mature. It's kind of a process, a growth. It goes through its little curve. And so one of the first things we did when McAfee became Intel is we knew that Intel had just gone through a PSIMM assessment. That's Build Security and Maturity Model. So trying to be a good corporate citizen, we said, okay, PSIMM, come and go through our program and tell us where we're good, tell us where we're deficient. And I spent several weeks gathering evidence, setting up appointments with engineers. We spent 3 days meeting with these folks, and just a lot of time and effort. And it was really good. We got a really good report. And PSIMM basically collects the activities from over about 100 different companies and says, okay, we're not going to tell you what's good or bad, but we'll tell you that 70% of the companies do this, 5% do this, 20% do this. You decide. And so that was a good model. It did cost time and money, as you'd expect. There's a SAM one, which is an OWASP standard for similar to PSIMM. And even within Intel, they had a DFS, or Design for Security. And the design for security was more focused on certifying a team, saying they've been trained and gone through the processes so they understand the security. It didn't focus so much on the tools and how they used them. So how? How do we measure how well? So our team came up with what's called the Intel Security, and whenever you see Intel Security, that's a code word for McAfee. We're part of Intel, but they call it Intel Security. But the Intel Security Product Security Maturity Model. And that's what I wanted to present here. And the purpose of this is to measure, again, how well your program is running both operationally and technically for all aspects of your product security program. More importantly, it needs to provide a simple yet powerful model, and it has been adopted within Intel. I've met with all 8 of the security leaders of the business units and presented it to them, and they're actually using this. And I always tell them, don't worry about perfect data. You have to start somewhere. If someone says we don't have that data, you know what? If I ask them a year later, they'll still say they don't have that data. So you know what? Start now, and then a year from now, at least you'll be a year ahead. So that's a dumb excuse. Just do it. Now, I was given several constraints, and these may be familiar to you. One of the constraints was I said, okay, great. Do I have a budget to buy a great tool that can do all this? I'm sure there's many things out there. Give me a tool. They go, no, don't have any budget. In fact, if you want budget, submit it now, and then in next year's budget cycle, we'll put it in there and you might get it. It's like, okay, I got to wait at least a year for that. And then one of the other things is, okay, we have a program. How do we ensure that it's the integrity of the data? Well, do we need to hire some auditors? No, we've got 3 auditors over here. They can do spot checks, but we're not going to hire an army of auditors. So, okay, get it. I wanted this to be very simple. So, I mean, simple to me is hard but better. If you can make something simple, it means, one of my favorite quotes is by Albert Einstein. He says, if you cannot explain something simply, then you don't understand it well enough. And I've learned the better you understand something, the easier you can make it simple as you communicate it to various audiences. So keeping it simple. I wanted it as automated as possible. Again, my motto is make the computer do the work. I'll automate things as much as I can. I don't want it to be weighted. If you weight scores and say, this score is worth twice this score, then you're playing politics and you have no idea what the data is going to do, so keep it non-weighted. Minimal training. I want it to be low overhead. I had engineering directors and VPs say, if you give me a program, you're asking me to tell all my engineers to do something. That's one more layer of things that you're taxing my developers with. You better keep it down to a minimum because I'm tired of this always building up and never going down, like a tax that never goes away. And then, of course, our governance team says we want to have insightful metrics that we can roll all the way up to the top level. So these were the constraints I was given. And so based on that, we deployed a solution. And some of the early feedback we got was they said, okay, let's provide a document, like a Word document, that explains the program in detail. So you can just hand it to somebody and they can refer to it. So yeah, we got that. And then someone said, we want to do the scoring, so let's provide drop-down lists in a spreadsheet. Okay, makes sense. Let's allow or adjust for not applicable. So if you have a security task like static analysis and it absolutely does not apply to that product release, maybe it's an Internet of Things release and it just doesn't make sense, then give them a choice to say not applicable and have it not impact the score in a silly way. Some asked that we map this to other maturity models, and I showed 3 of them to you, which we have mapped them to in the document. And others will say, I want to do a phased rollout. If I can't get this to all my engineers right now, what can I do to have meaningful data? So again, these are some of the feedback we had to incorporate. And again, what we're talking about is measuring those 20 parameters and how well they're being done. So the way I look at collecting data, I look at least where I work, there's 8 different levels. The entire corporation, in our case, Intel. And then we have, Intel has 8 business units, really big business units, like McAfee is now a business unit. So they all have their own personalities, some nuances inside there. And then each of these business units have, in number 4, they have product groups, and those product groups will have individual product lines. I don't ever go down to 7 or 8. They were suggested, but I put them there because I can't go any lower than 8. So I figured I'd put it there. So what I'm showing you this because we collect data at level 3, 5, and 6. Level 3, 5, and 6 are where we collect our data. We started at level 3. We went then to level 5, and then we went to level 6. And then we even compared the data, which I'll show you the differences in the data between all 3 levels. It's very enlightening. And as I say, data can be collected at any level, but the lower the level, the better. Here's what I mean. Let's say if someone asked in the company, how well are you doing security architecture reviews? Well, what do we say? We say 80% of the time we're doing them. Well, if we go down to a different business unit, you might say this one does it 100% of the time, this one never does it. Okay, if you go down to the product level, you can then aggregate all the products into the group and then the group into the company. So again, you get more data. And we ask that they refresh the data every 6 months. And in the typical organization, I don't want to spend much time on this, but I wanted to show that in our organization, product security group in red, we report directly to the quality group because they have quality, they have product security, and they have the agile. Those are the 3 main areas. And in our group, I'm considered one of these senior product security architects where I help manage the program company-wide. And I have a group of 55 senior security engineers that matrix report to me that are co-located in different development engineering teams. And they are with the engineering groups making sure that security is forefront in their minds and done. They're the ones leading the security reviews. They're the ones helping with the patches if there's an issue. And we call them product security champions. And again, a product security champion is someone who is dedicated up to 20% of their time to do product security. The rest of their time is doing engineering development. They have VP of engineering support, so they're not always being pulled away. And they're there to mentor the team for product security. So we do this by leveraging, I call it a 20% tax on one individual per team. And we found that we're like 90% staffed at any given time. And we found this was a much better approach than simply going and saying, I need this much more money for this much headcount so I can put people in every group. So again, we're trying to be creative with what we have. In fact, this is so successful that the privacy team has come to us and said, man, you've got product security champions in all of the labs. We wish we had that too, but we're a little bit smaller than you. So we said, okay, we'll let you piggyback on us. We'll work with you. Privacy is important. And just for fun, I put down the typical titles that you would see in these groups. I've been using the word PSC and other things. If I use these words, this just gives you an idea of what some of the roles are. It's not super important for this presentation, but just know that we have different roles at different levels that help make the program successful. Now, again, before I get to the fun stuff, I'm just showing you some of the fringe stuff, then we'll get to the fun stuff. One of the questions is, how do you keep it honest? And based on experience from the past, when you have a program, we've actually had some engineers say, we're at the top level of this certification. We're so smart, we don't have to do that task. We've also had engineers that say, we're not even at level 1. We're not smart enough to do any of the tasks. So either way, they're too smart or too dumb, and it's a dumb excuse. Okay, so it's laughable. Okay, so the idea is they're trying to get out of it. Well, to keep it honest, first of all, we ask the product security champions to score their own products, period. And if you don't know, guess what? You have an engineering team, go find out. And then we have PSCs to peer review other product security champions. That way they can have a dialogue and say, well, I scored it this way, but I scored it this way, but our programs are the same. They should match. And then we have the lead product security champions, which they're over a whole product group. they will score their own product groups from their perspective. So let's say I might have 20 products. As a whole, how do I think we rank for all 20 products in the scale of maturity? And then they review each other. And finally, we have a governance team that will go and do spot checks, or rolling audits, they call it, just to keep it honest. And this I show you because this validation keeps it very low overhead. We don't have to hire an army of 40 auditors to run around and make this happen. Believe me, they've asked. It's not happening. So I showed you these lists before. And so for this maturity model, what we're really doing is we're measuring on a scale from 1 to 5, or actually 0 to 5 if it doesn't apply, of all 20 parameters you see on the screen here. And if you think about it, if the highest score you can get is a 5, and you have 20 parameters, the highest score you can get is 20 times 5, which would be 100. So it's like, oh, 100%. And of course, the lowest you can get is a 20%. There are no zeros. We're on a curve. And so this is what we're doing. And each of these tasks, most all of these are required for every development. We actually have some qualifying questions we ask that will perhaps say, like privacy may not be applicable if there's been no architectural changes or no effect of PII or whatnot. But in general, these are all the tasks that get done. And so let's just take a level. Let's go to technical level 4. And I'll show you the levels. Level 4 says you're at acceptable level of security. Again, what they really are is level 1 is none. Level 2 is basic. Level 3 is simple. Level 4 is acceptable. Level 5 is mature. And you want to be at level 5. And so here we're showing these 12 technical parameters. These are where we expect the teams to be at an acceptable level. Now, a better way of looking at this is taking a single one of these parameters and just seeing what are the 5 different levels and what does it mean to be in that level. So I picked security testing just because I had to pick one of the 20. And you can see none. There's no security plan. We're just not doing much. Level 2 initial, we have a security plan. We do it once in a while. Level 3, we've done it at least once before release. And we're actually doing functional testing. We make sure the features work. Level 4 is we're doing the testing several times before release. And we're even doing negative space testing, not just functional. It's what the hackers know for out of not intended behavior. I call it the monkeys pounding the keyboard. And level 5 is you're doing this constantly before and after the release. And the idea is if you can get to the mature, you're at the best level. You're getting the most bang for your buck, your time. And one of the things that came up as I was sharing these with the different teams at Intel is they wanted to make sure that this model, that each of these levels had at least had a process and a quality of execution component. Because there's a difference. There's process is what you're doing, but the quality of execution might be another. So give an example. If I have a tool like static analysis, the process could say I run it once a quarter, I run it once a month, I run it nightly. Okay? It's how often you run it. The quality of execution would be the results I get, I fix right away, or I don't fix them and I have a bigger technical debt. So the quality is what you do with the data, while the process is like how often and how much code you run it on. And so wherever I can, I put both of these together in the requirements. And I kind of look at it from the IT side. Are you compliant or are you secure? Compliant means you're doing what you're supposed to be doing, but secure means you're doing it right. There's no technical debt. So the heart of this program to do a score is to get a score and get it every 6 months and roll them all up for metrics. And like I said, I automate everything, and the spreadsheet was already on my laptop. I didn't have to buy anything. So what I'm going to do here is I'm showing you a few screenshots of the spreadsheet to give you an idea what I show the engineers when we implement this. And then I'm going to show you some of the metrics, or these are mock-up, but typical type metrics you would get from this. So in Excel, I define all 5 levels for all 20 parameters with a single line. Why do I do that? Because most engineers aren't going to pull up the Word doc and read the whole thing before they do a scoring. They're just lazy or don't have time. But they can read a quick list and choose something. And to me, that's good enough. We can educate them more as we go along. So these are used for drop-downs. And I picked threat modeling, for instance, because I didn't think you could see this. But again, just like we showed you with security testing, you'll have the not applicable and then the 5 levels. And basically, you just pick one, and it shows up. The scoring, as I mentioned, is from 20 to 100. So we defined what the buckets are and what defines whether you're in, whether you're considered none, basic, initial, acceptable, just so you can see where the line's drawn. They're simple, they're not weighted, and we show them for operational, technical, and combined. So here's what we give to each of the product teams, the product security champions. We say, okay, you're over Virus Scan Enterprise, for instance, over big products. Can you answer these 12 questions and do it once every 6 months? And just send the data to your product security champion lead, you're done. So they look at these parameters on the right. They look at this. They're all set to 0 initially or 1 initially. And then they actually go in there and they click on the drop-down. And it'll pull up a list and they'll grab one. And so it really doesn't take that long. If they know their program, they can do this in a couple minutes. If they don't know their program, they got to ask some questions or get a team meeting together and say, let's do this as a team. Either way, they get this information, generates good discussions. And then the scores are automatically calculated on the bottom. In this case, a 3.8 is above 3.5, so they're at level 4 acceptable. So we take this data, and then one of the things we can do is create a spider diagram. They also call them radar diagrams, but I like the word spider diagram. It's kind of cooler. And what it does is it shows anything that's in the outer rim is really good, and anything in the inner circle is not being done. So right at a glance, I can look at this, and I'm thinking, fuzz testing. They're not doing fuzz testing. Fuzz testing, it was invented at a university where you basically take a running program and you send it data, but you tweak little things. Like if it's expecting a certain packet with a certain header and certain data, you tweak a few bits in the packet header or in the data, or you make the data a little bigger than it should. You just tweak little things that shouldn't be done. And you see how the program can handle these edge cases. And they may all do fine, but when you can automate this and send 1 million an hour, you start getting systems that crash. And when it crashes, it records that and says, I've seen people run this tool for a week and come back. They actually came to us and said, you know, we're a big bank. We hired an auditor. Here's 7 medium to high vulnerabilities that we found using fuzz testing. So I go, thank you very much. We'll fix them. And then I look to the engineers and say, you guys are supposed to be the smartest security guys in the world. How come you didn't find them first? Okay. You know, probably not the nicest guy to motivate, but it's like, hey, I don't want to keep getting these from customers when we should be able to do it. Okay. So and it may be that they don't need fuzz testing, or this may be a way of saying, we really want to do fuzz testing. Can we get a tool? Now, there's a tool that's free. It's called Peach Platform, or the Peach Fuzzer. I've actually been trained on it. So it's kind of cool. You just, again, you tweak with parameters and let it go. But it takes some training. You have to understand the protocols and how to set up the packets. So that takes some time. There are some teams within our company that are using a commercial one called Codenomicon. Codenomicon has about 150 protocols that it's already got the package set up, and you just let it loose and it finds stuff. But it's not cheap, but it's very good. So this could be a justification to say we probably should get more licenses for more of the engineers. But the point is, when you look at this diagram, I actually don't care about this at the level I'm at, because this is at a single product level. But this is what I want the product engineering team and those above them to look at and ask the question, is this acceptable? Is this representing the business risk and the budget that we want to do? Would we rather do less on security planning and get some training on fuzz testing and balance this out? Again, it's your call. not really a right or wrong, it's just a, here's where you are. So this is what it looks like with the technical. Now then, I go to the product security leads, and the leads are, they're over up to 20 different products. And I'll say, from your perspective, just looking at all your products as a whole, how would you rate your business group? And so they have to go through here and list what they think on average their business group is. And then because they're once removed from engineering, I ask them to do the program as well. How well are we doing in the program? You know, how you trained? Are you getting instant response? Those kind of things. So they enter this, and you'll see, again, the scores come out for both operational and technical with a combined score overall. Now, anything in gray is automated. It's a formula. And I tell you this because I included the spreadsheet that created this with my PowerPoint presentation. So if you're interested in this, when you go download my presentation, you can download the spreadsheet and even the Word doc and have fun with it. Okay? It's not proprietary. Now, when I look at this particular one, according to this, again, I changed the data, but according to this data, the product security champion lead says this is what he sees on average for his BU. And this is the operational side. Again, you can ask the question, are these 8 ones invested properly? And then you can also look at where they see they are in the technical. So again, this is at a higher level, looking at lots of different products in one group. Well, once these engineers submit the data, it all goes into a spreadsheet where we just list the numbers right here. We list the product, and we put in their scores. And again, magically, the numbers come out. So anything white was manually entered. We just put them right in there. Pretty straightforward. And we do it for each of the product groups. And I put things in there like 89%, meaning I'm not 100% complete, gives me an idea. Those kind of things. Then I have another tab that takes all that data and rolls it up. So it does the averages for all the groups. In this case, we have 6 product groups for the 100 or so products. And alongside it, it puts the scores that their business unit group lead thinks they're getting. And so again, you can see it from the product group lead and then from all the products. So with that, we can get different metrics. And one of the highest level metrics, this is the second highest level, this is actually a stock chart. Stocks have high, lows, and averages. You can use a stock chart to show the best, the worst, and the average of all the teams that do in product security. So if we take all the scores that were in that earlier table, you'll see on average, I see a 3.5, a 3.1, a 2.1, different scores. A 1.2, it might be a brand new division, it might be a new acquisition, or it might be a problem child, someone that's never listened and we have to work with them. Okay, so you get different reasons. Now, I call this from product data. You're collecting it, ideally this is from 100 products. And I call that the most accurate. Now, if I just go to the 6 product group leads and say, what's your scoring? Oh, before I do that, we set the bar at 3. We initially want every group on average to be at a 3. And as soon as we get them to 3, we're going to bump them up to 4. And we're not going to make them go from 4 to 5 because the cost from going to 4 to 5 may not be worth the investment. If you can go there without breaking the bank, great. But it's the 80-20 rule. You don't want to do 80% more work to get to the last 20% unless it makes business sense. So getting them out of this box and up to the 3 is our initial goal, and then up to 4 over the next year or so. So if I go to the PSC leads, I call this somewhat accurate. I get similar data, but very different averages and whatnot. It might not be the same data. Well, what if you don't have all the product data? Well, you rely on this because this is better than nothing. And before we got data like this, we went to the product security group with a director and a couple architects and say, we've been working with these teams for the last 3 or 4 years. We know them pretty well. How would we rate them based on how we interact with them? So now you're asking 3 people to get the data that would normally take 100 products to get, and you might get scores like this. I call this least accurate, Because here you have 3 people, here you have 6 people, and here you have really 55 people for 100 products. So I remember I said on the org chart, I do things to level 2, 4, and 5. This is what I'm talking about. And I wanted to show you how the data can vary based on which level, but at least you have something. The highest level metric on the dashboard for the entire company, our metrics dashboard, could look something like this. Or you have a maturity scale. You've got the levels on the bottom with a few bullets here to remind what might be in different bullets. And then based on the score, you can say our business unit or our company or even our product group is, put an X there. And over time, you can see how that's moving up or down based on, turnover, new tools being bought, whatever happens to make it change. So this is one for operational. It's just a very simple slide. It doesn't show all business units and their bars. It just shows one dot for everybody. We have a similar one for technical. Again, you would put a dot where you think you are in the technical space. If you put it all the way to the very top, you would have no reason or justification to get any of the great tools you want to get for security. So you may not want it up there unless you already have everything you need. In this case, we're wishing we had a few other cool tools. And then the last one is, as I mentioned before, you get the most bang for your buck when you do the first few stages. You can get to level 3 pretty quickly without a lot of operational overhead, but it's a tractor pull when you get to the last part, where you're spending a lot of effort to only get that extra 5% out. If you can do it, great. But at Intel, we have 107,000 employees, and you got to choose your battles. And so that's where we're starting and where we're trying to head. And again, you can put technical, operational, whatever, right here where you think you are. And so the 3 key takeaways I wanted to cover in this meeting, or this presentation, is 1, every company that develops software should have a SDL, Secure Development Lifecycle, with things they do to secure their products. And if you're not developing it and you're acquiring this from somebody, let's say you're an IT shop and you're acquiring products, you have every right to ask them, what is your SDL? Are you an ISO 27034 certified? Are you working on it? Do you do static analysis? Do you do these things? You can ask them. Now, if they say no, then you can think, okay, there's some risk there. If they say yes, then you can say, can you give me documentation? No, just ask the questions. The second thing is you could say you're doing it. I could say I'm doing dynamic analysis, which is, what does the program do when it's, how does it, handle memory crashes, those kind of things. How well is it being done? Again, there's different models you can use, some PSIMM and OWASP, but we created one that was simple, used off-the-shelf tools, took only a few minutes of the engineers, low overhead, not a lot of auditors. Let's just get it done. It's not that big of a deal. And we call that the PSMM. And from this, we're getting metrics that we're rolling up in an executive dashboard all through those levels of the organization. And this is something that's important to our organization. They want better security metrics. They want to make sure that we can show that our metrics are backed up by deliverables. And I've been working on the team that's starting at the top level and doing the dashboards, working our way down the organization. For instance, PCERT, the incident response. I spent a lot of time updating the last 5 years how many different vulnerabilities we've had in the products based on severity. And we've listed those out so the executives can see the trend. Are we getting more and more high severity vulnerabilities? And we found some interesting things. We found that what the Intel security group is having problems with is not the same as what the Intel hardware group is having problems with. Our biggest hit recently has been third-party and open source software. Can we say OpenSSL? Can we say bind or be safe for encryption? Those kind of things, even Java. The engineers use them, but when we use those things, we accept all the good and the bad with them. And when we get vulnerabilities, then we have to get a patch from the vendor, recompile, send it out as an update, And we're finding that 80% of our vulnerabilities are coming from these third-party libraries, maybe even more than that. So one of the things we've implemented in our company is to have a certification program where an engineer has to list, their teams have to list all the third-party and open source products they're using and submit it to a team that will then look and see if it's on a whitelist or a blacklist. And if it's on the blacklist, then they'll say you can't use that. If it's on the whitelist, we say we've already looked it over, keep going. So that's one of the things we're trying to do to mitigate that risk. But again, you want metrics to drive change. And so these are the three things I was trying to build up. Again, I submitted the Word doc, the spreadsheet, the PowerPoint, all to Bill, so they can be available. And if you want, you can reach out to me. I'll be glad to share. Any questions? Silence is consent. Okay, well, thank you very much, and enjoy the rest of the afternoon.